So you have a microservice written in Java, and your dream is for that microservice to start producing telemetry data such as metrics and traces without you touching a single line of code of that microservice. Is this possible? Well, guess what? It is. In this video, I'm going to show you how to do this using the OpenTelemetry Agent for Java. Let's do it. Hello there and welcome. My name is Ricardo Freire and I'm a developer advocate here with AWS. So let's recap. You have a microservice that has been written in Java and it uses technologies such as Maven and Spring Boot. But currently that microservice is not properly instrumented to produce telemetry data such as traces and metrics. Therefore, whoever is using an observability backend is not going to be able to see whatever happens as you execute that microservice. So in order for you to change that, you have to undergo this process called instrumentation. And then there are different strategies of instrumentations available out there. We're going to discuss now these different strategies because I truly believe that one of the major concerns about how OpenTelemetry is seen as a complicated technology comes from that understanding. So let's discuss what we call black box instrumentation versus white box instrumentation. The most important aspect that you have to understand about the differences between the white box instrumentation and the black box instrumentation is that depending on which approach you take is going to dictate how much effort you're going to take to start implement observability in your applications and microservices. So as you can expect it, black box instrumentation doesn't require you to change the code for this to happen. Most of the time, the approach that's being used is going to infer a set of constraints about what your code is doing. The trade-off of this is that it's not going to be able to provide the complete visibility about what the code is doing. Certain things is going to be simply inferred, and some others will be simply discarded because it cannot possibly understand what your code is doing, right? Whereas in using the white box instrumentation, you have full control of what your code is going to produce in such a way that whoever is using an observability backend to monitor your applications is going to be able to understand and see what's going on with your code. That requires you to change the code, and therefore it requires you to not only have programming skills, but also to learn a specific SDK or library implementation for that particular observability backend to be able to understand what the code is doing. So in terms of visibility, who provides the best visibility ever? Definitely is the white box instrumentation because you have full control about what the code is going to show to whoever is monitoring your applications. The black box instrumentation provides limited visibility, but there are use cases where this is going to be useful. It highly depends on the type of architecture style the applications and microservices are using. So if they are extremely decoupled, based in a sense that each unit of execution is so small, you might benefit for using a black box instrumentation, especially the ones provided automatically for architectures such as Kubernetes clusters and services mesh architectures. But even if you are using a specific technology written in a programming language such as Java, you might also benefit from this. Speaking about Java and programming languages, one of the main sources of confusions about why OpenTelemetry is so complicated comes from that understanding because most of the time, the experience of how you are going to use OpenTelemetry differs very abruptly depending on the programming language you're using. So for example, in this video, we're going to explore how to do this with Java. And we're going to see that the approach is almost automatically. Therefore, we're going to be using a black box instrumentation. But the same is not available for all the other programming languages. So if you go to Go or Python or .NET or JavaScript, you're going to see that most of the time you are going to actually have to open the code, make some changes, and therefore you're going to be more abounding to the approach of white box instrumentation versus the black box instrumentation. But regardless, it is important for you to understand that depending on the programming language that you are using, the amount of complexity for the instrumentation process is going to be different. Now that you are up to speed about the differences between white box instrumentation and black box instrumentation, let's take a look at what would take for us to instrument a microservice written in Java using the OpenTelemetry Agent for Java. which comprehends the approach of using the black box instrumentation. So just a FYI, the OpenTelemetry project is broken down into multiple different projects. So each one of them focusing on one particular aspect of the OpenTelemetry project, such as the protocol, the specification, and there are one for each one of the most common programming languages out there. The OpenTelemetry agent for Java is available in the OpenTelemetry project for Java. So there are many distributions of the agents, but all of them derive from the same base code from the OpenTelemetry project, and that's what you have to pay attention to. So this is, we're gonna right now change the script that executes a microservice, and by the way, if you are coming from the previous parts of the series, you probably know what, how, where, and how to get the code for the microservice implementation. If not, just take a look here on the comments below. You're gonna find a link of the GitHub repository that contains the implementation of the microservice. Just be aware that we are using this particular branch here called Build on AWS tutorial. That's purposely incomplete because we want to fill it with the code. So to change the microservice implementation, all we're going to do is basically change the script that executes the microservice. So as you can see here, what the script currently does is to force a Maven build to generate a fresh copy of the jar file from the code and then execute the code from that jar file. So what we're going to do now is actually change this script slightly to perform one additional step, which is downloading one of the distributions, one of the many distributions of the OpenTelemetry agent for Java. In this case, we're going to be using the distribution from AWS. There are many distributions out there. So most observability vendors create and derive their own distribution from the base code from the OpenTelemetry project. This is all you got to know about the distribution, whether they are compatible and derived from the base distribution. Otherwise, you're going to be getting to the risk of not being fully compatible and compliant with the OpenTelemetry specification. It is not the case of the AWS's distribution because it is fully compliant with the base code. So as you can see here, basically what the script does is to download the jar file that contains the implementation of the OpenTelemetry agent, and then it's going to use that agent along with the jar file. So in order for this to test this, let's do the simple test of executing this script so you can see the differences. So if we execute the run microservice.sh script, it's going to force the Maven build as it's supposed to. You're going to check if the agent is available locally. If not, it's going to download it. It probably is available yet. And then execute the microservice in Java. So the behavior is the same. So as you can see here, in order for you to test if the behavior is exactly the same, you can send one HTTP request to the microservice. So what we're going to do now is to perform a curl request to send a GET request to the endpoint HTTP localhost 808080, which is the port that we're using for this microservice, and the URI/hello where the endpoint is available. So as you can see here, it simply reply back, hey, hello world. So the behavior of the microservice continues to be the same, but now you keep probably wondering, but what is the difference? So we're using an agent along with the microservice. What is the actual difference? The difference is, although you're not seeing it, the microservice right now is actually already trying to send the produced telemetry data from traces and metrics to an endpoint. By default, as you can see here in this log entry here, by default, the agent for Java tries to send to an endpoint that is available in a given interface over the port 4317. So this is the default OTLP exporter, right? So what we can do for debugging purposes, just to make sure that everything is up and running as expected, is to change the exporter right now to, instead of trying to send to this endpoint, which is the default, flush into the logs. So you can easily do this. I'm going to stop the execution of this microservice right here, and then I'm going to include two additional environment properties here on the script that is going to inform the agent for OpenTelemetry that, all right, so for the traces, I want you to flush all the traces into the log. And same for the matrix. So I'm going to export the matrix into the log. Only by doing this, you can start executing your microservice one more time, and is not going to change the behavior of the microservice. That's the whole purpose of the black box instrumentation, right? And the difference is if we send a new request to that microservice right now, and I'm going to actually reuse that curl command that we've used before. So I'm going to just send the request as expected, hello world. The difference now is that you're probably going to see that in the logs, here specifically, it just emitted a log entry that represents the root span of one trace. So this is the actual trace that was generated for the invocation that we've just sent using the curl command. And in a couple seconds, you're going to see that the log itself is going to start popping up a little more verbose additional log entries that is going to be the actual metrics that are periodically collected by the agent from the JVM and is trying to emit somewhere. But this somewhere right now is the actual log. So the collection period by default, I think is up to 1 minute. So as you can see right now, it just started popping up the metrics that has been collected at this point. And each one of those entries here represent one particular metric and their data type and their current value. So in the future, we're going to learn how to create our own metrics. But for that point, just realize that without touching any part of the code, we're able to instrument our microservice to produce and emit traces and metrics that are fully capable to be used somewhere else. In the next videos of the series, I'm going to show you how to use the OpenTelemetry collector to start receiving those telemetry data and make good use to it. Until there, I'm looking forward to see you in these future videos as soon as possible.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.